we move ahead to the next module of Hertz observation. Now in this Hertz observation, there was a scientist who is Hertz. Now this Heinrich Rudolf Hertz scientist was performing an experiment on electromagnetic waves, in which you can see what he has done. He has taken a source of light. On that source of light, he has kept a prism. Students, with the help of prism, you can get different constituents of light, and you can obtain a monochromatic light, that is light of a single frequency or a single wavelength. He emitted that light onto a thin foil, and you can see something coming out of that thin foil, some particles which are coming out. So students, what is happening in this case, that this whole setup is kept in a vacuum, and this guy, this Hertz, was performing experiment on electromagnetic waves. While performing this experiment, he observed that there was some spark which was conducted in this particular vacuum setup, and this spark was obtained more easily when there were light which were of UV light. So when this whole setup was illuminated with the help of UV light, he observed that there was electric spark that was generated. This electric spark that was actually generated was really electrons which were getting emitted from that thin metal foil to the collector. So in short, there were electrons which were generated with the help of light. He did this experiment and he came to certain conclusion that there are negatively charged particles which are generated, because at that time they never knew that these negatively charged particles were actually called as electrons. So this discovery was at that time called as the Hertz effect. But now, students, this is known as one of the most important effect, that is called as the photoelectric effect. And to study photoelectric effect, there were two scientists, William Helmholtz and Philip Lenard, that showed this Hertz observation even in more better way by taking out few points. One of the critical point that they gave was that electron emission, electrons getting emitted, occurs only at a radiation in which the frequency is above a critical frequency, or the light is having the wavelength below a critical wavelength. So they told us that emission is occurring only when the light is having frequency more than a certain frequency and a wavelength less than a certain wavelength. They also told us that the kinetic energy, the energy of the emitted electron, increases with the increase in the frequency, or it decreases with the decrease in the wavelength. So we understood that this was the relation which was there. Hertz observation also told us that the alkali metals were the most suitable metals for photoelectric effect. Do you all know which are alkali metals? Why alkali metals were the most suitable ones? You can see these alkali metals which are there. Alkali metals like cesium, potassium and sodium, they emit electrons or photoelectrons even when the visible light is incident upon them. And with the help of that, we came to a conclusion that even in the visible light, these are those materials which will emit electrons, so they are the best for the observation. That is why alkali metals were the most suitable ones for studying the Hertz effect, or which today is called as the photoelectric effect. Thank you.